Lab day, rate of the iodine clock reaction. I tell you guys, it's really is a shame that you guys don't get to be here for this one. This is a fun lab. I really enjoy it. Usually students enjoy it. And I'm going to be honest, it's way more fun to do in person. But we're going to do our best to get a little bit of the experience here. And we are going to try and find a rate law. That's our goal. Now, because of the fact that we're online here, I'm going to shorten this up a little bit. We're not going to do 100% of it. Our goal, so let's just put it here. Our goal is to find the rate law. Okay, that's our whole goal. Let's find a rate law for the reaction. Now, the reaction that's going to be taking place is basically a reaction between, let me go ahead and highlight it here, this guy right here. These are going to be our two reactants that we are starting with in this chemical reaction. So we have some iodate and we have some hydrogen sulfite, and these two things are going to react. And our goal is to try and figure out what the abbreviated rate law is. Okay, so I'm not going to do so many trials that we get to figure out everything here, but we are going to try and figure out at least one of the orders. Okay. So when we look at our mixing table here, you'll notice that, remember that you have to change the concentration of one while keeping the other constant. You'll notice that this one is held constant the entire time. So we're never going to actually be able to find the order of the HSO3 minus. There's just not enough time in order for us to do that. But we can at least get the idea that if we hold this constant, it shouldn't have any effect on our rate. We are going to be changing the concentration of this IO3, so we should be able to find the order for that particular one. So how are we going to do that? Well, we're going to look for a color change. That's the key here. Because remember, when we find these things, you need to have something that's measurable. And so either it's generating a gas or something like that. And so this one's going to be a color change. The minute we see a color change occur, our reaction is done. That's the neat thing about this particular reaction. So without getting too technical here, I wrote a lot, and then I always go back and I see how much I wrote, and students don't 100% get it, but I'm just going to try and give you guys the gist of it here. Basically what's happening, the reason that we know when the color change occurs, the reaction is over, is because what's happening is sort of a mechanism. We've been talking about mechanisms, so that shouldn't be an unheard of thing for you guys. You know that it's going to occur in several steps. This is not a reaction that just occurs in one step. So what happens is, in step one, the iodate, the two reactants that we have, basically combine and they make a product. The product that they make, the one that we care about here, is this I minus. And the reason that I care about this I minus is because I just want to point out that it's an intermediate. Okay, this is something that is going to go away. It's not going to stay present. It shows up for a little bit of time, and then you can see it right here, right? It's going to get used up. And you'll notice what's using it up, right? It's reacting with one of our reactants again. So not only is the IO3 reacting with this, the IO3 is reacting with the intermediate that's forming. Sorry, I got a scratch in my throat here. I had to get a drink of water. So we've got the intermediate forming and then getting used up again, but you'll notice it's not like a reverse reaction where this and this react to form this and then it turns around and goes in the other direction. It's that this is reacting with the intermediate to make something completely new. And that is the important piece. So I'm going to highlight this one in red. The reason that this is important is because this is what is going to give us our color change. If this starts to build up, the minute that this starts to build up, a color change pops. Now, the reason that it doesn't build up is you'll notice that while the IO3 was able to interact with one of our products, well, guess what? The other reactant can mix with this one. And so that's what our equation down here is doing. And you can see that the hydrogen sulfite is reacting with the I2. So basically this is hitting the intermediate, but then when this forms, this breaks it down. Now, so we sort of, what's kind of happening is our reaction is sort of going in a circle like this, right? we're creating some products, but then those reactants are breaking those products down. And then we create some more products and the reactants break them down. And so we keep doing this. But what actually is going to happen is this guy right here, the HSO3, see if I can find some space. Maybe I'll do it down here. The HSO3 is our limiting reactant. This one I'm putting in the smallest amounts. I'm telling you right now, that's the one that we're going to run out of first. Okay? So what's going to happen is we are going to know the concentration of HSO3 minus in the beginning, right? We're going to be able to tell that from this table right here. And what's going to happen is we're going in this circle, right? We make the I minus and then it turns into I2 and then the I2 gets destroyed. And then we get some more I2 and then it gets destroyed. And then we make some more I2 and it gets destroyed, but this time we used the last of our HSO3. So when the I2 forms, is it going to ever get broken down again? No, because we are out of this. And so since the I2 survives and it stays in the beaker, boom, we get a color change. And it's a pretty fast color change. And so at that point, we know our concentration of HSO3 goes down to 0. And remember, this is going to allow us to find rate, because how do we find rate? Rate is equal to the change, I'll put a delta there, the change in concentration over the change in time. So if we go, all right, well, I know the concentration in the beginning, I know the concentration in the end was 0, and you time this reaction, then you should be able to find the rate at which that chemical reaction was proceeding. So if that's too much for you, remember this. Color change, HSO3 gone. We done, okay? So let's go ahead and get to mixing here. Now, before we do that, this is the mixing table. This is not what has been on our worksheets, though. When we were finding the rate law on our worksheets, they did not give us milliliters. Right? They gave us a table that looked like this. So what's going to happen is as I'm mixing all of these, you guys are going to need to go, okay, he mixed 10 milliliters of 0.1 molar IO3 with 80 of water. What would that concentration be? And then he mixed 20 milliliters with 70 of water. What would that concentration be? Okay, so when we're doing that, I'm going to just give you a little direction right now. The concentration is changing, and we haven't covered this yet, but you did get this in first year chem. The way that we figure this out is M1V1 equals M2V2. So your original molarity will always be 0.10 molar. That is what we were starting out with, 0.10 molar. Okay, and then you have your initial volumes right here, right? 10, 20, 30 each time you do it. So those were your initials. What is it changing to? Well, the mixing table tells us that we're going to mix 10 of the original stuff with 80 water, and then we're going to add 10 milliliters of the other reactant. So my final volume will always be 100 milliliters. And so you will need to find your M2. The final molarity will go right here. All right, and then how are you going to find the rate? Well, we talked about the rate. We said that rate is the change in concentration over the change in time. So the time you should get from here, right? That's the time it's taking for our color change. And now what concentration are we talking about here? Well, we have been measuring, what were we measuring the time of? Not this, the limiting reactant. So you need to get some concentrations for that. Now we had originally 0.07 and we used 10 mLs, but did it stay 10 mLs? No, once again, you're mixing it with all of these things. So what would its concentration be in 100 milliliters? So you'll have to do this equation here as well. If that's tricky for you, you're going to want to make sure you pop in and get some help. But for now, let's go ahead and switch over to the video camera and we will get to timing, etc. So you're going to want to make sure you've got something that you can use as a stopwatch. I'm going to let you guys do the timing here. So let's get to it. Okay, so we are ready to get started here. So I've got our first set of information ready to go. So basically, if we slide the camera over just a little bit, we can see the different chemicals that I have out and ready to go. So remember that our mixing table here tells us that we need 10 milliliters to start with the IO3. We need 80 of the distilled water, and we need 10 of the bisulfite. So when we look over here, we can see that I've got the 10 of the iodate, I have the 80 of the water, and then this one is 10 of the HSO3 minus. So we're gonna go ahead and get all these things mixing, but I have to be really careful, and you guys have to be really careful on when you start and stop this. So let's scoot it over so we can get a better view of our beaker here. The order that we put it in doesn't really matter. So I'm gonna put the water in first to sort of give me some substance here. So I'm putting the water in. And I'm gonna want this thing to start stirring. Now, because I'm doing this myself and I don't have any group members here to help me out, it's gonna be really difficult for me to stir, time, write, and pour all at the same time. So I am going to cheat a little bit. Now, when you stir this, remember that we have to be really careful since we're finding the rate that we hold certain things constant. We want to make sure that we don't add any catalysts. So I've made sure to wash everything in distilled water to make sure that there's no metal catalysts left behind from tap water. I don't want to stir faster in one reaction than I do in another. I want that to be pretty constant, right? We want to keep the temperatures the same. We want to keep all these different things the same. The only thing we want to change are our concentrations. So to help me out with that, I have this is a hot plate, but it's also, you'll notice it says it's a stirring hot plate. Some of you might have seen this before. This is basically a magnet that is covered in plastic. And then there's a magnet inside of here. So if I put this inside, you'll see that it's stirring, right? I can turn it off and it'll stop stirring, or I can turn it on and I can pick whichever speed that I want it to go. So let's find a good speed for us to use here. Kind of clanky, but that's all right. So let's go, I think right on 4 looks pretty good here. So we're gonna leave it on 4. We are gonna go ahead and pour one of them in. So I'm gonna go ahead and pour the iodate in next, but once again, we don't have a chemical reaction yet because we haven't added our other reactant. So now, at this point, this is where it gets tricky. We have to keep things constant, right? So we have to make sure we start timing in every trial at the same point. So either I go 1, 2, 3, and then you start as I dump it, or I dump it and set it down, and the minute this touches the table, you start it, or whatever you're gonna do, but you wanna try and be consistent. The more consistent you are, the better your rate law is going to be, okay? So I'm gonna start, you're gonna start, make sure that we watch it close. You guys are actually lucky you've got a video here. You can always rewind it if you screw up. In class, if you screw up, then you have to redo the lab. So here we go. We're watching for a color change. So remember that the minute our HSO3 runs out, the I2 starts to form and boom, we get a color change. And we know that the HSO3 minus is gone. Waiting for that bell to be done. Okay. Here we go. All right, there we go. Did you catch it? I hope so. Okay, then that was trial 1. Make sure that you record the time that you got, or start rewinding if you missed it and you have to fix it there. I am going to go ahead and set up our next trial. Okay, we are starting in on trial 2 here. So for this particular one, remember that I had to decrease the amount of water a little bit because we increased the amount of the iodate. So we had basically 20 milliliters of iodate being used here. So I'm down to 70 so that we maintain that overall 100. So to keep the speed that this was turning perfectly constant, I didn't touch this. I just unplugged it. So the minute I plug it back in, our dial still should be right at the exact same speed it was in the last. So hopefully we can rule out any inconsistencies in our speed of stirring. So let's go ahead and plug it back in. And we'll move that around a little bit. So we should be, ooh, good, we got a little, let's see if I can get a little quieter. Better. Okay, so we got our speed there. So we've got the first one in. We're gonna go ahead and add some more to this. So we're gonna go ahead and put the 20 milliliters of the iodate in. Once again, don't worry, we're not starting yet, not until we get our last chemical in the second reactant. Okay, and so now this one, remember, is the same amount as we had last time because this is the one that we're holding constant every single time. So make sure that you guys are paying attention. Are you ready to start? Okay, so we're gonna go 1, 2, 3. That one was a fast one. I hope you guys caught it. You should have been expecting it to take less time because we had a higher concentration, right? So that one was pretty quick. Let's go ahead and mix up and get ready for our last trial. We are now into our third and final trial. So remember, guys, this time we have 30 of the iodate. That's the largest amount in the 100 milliliters that we've had so far. So we should expect this one having the highest concentration to go the fastest. So we want to be ready for that color change there. But for the sake of consistency, I'm just going to go ahead and put the water in first. So remember that I've reduced the water in this particular trial to 60 milliliters. And I have 30 of the iodate. So we're going to go ahead and put that in. And then once again, I didn't turn it off. I just unplugged it to keep the dial exactly where it was. Get that last drop in there. So let's plug it back in and get it stirring. Okay, try and get it a little quieter. So we've got some stirring there. We're gonna go ahead and get ready. So make sure you have your stopwatches ready. And we've got the constant one, the 10 milliliters. So hopefully we can start it at the same point. So I'm gonna dump it on 3. 1, 2, 3. All right, did you catch it? Hope so. I'm gonna go ahead and record mine. I was a little twitchy on the trigger there. I kind of hit it, but it didn't go off, thank goodness, too soon. All right, then we should have all of our data here. And so now we can start taking those times and turning them into rates. And we should be able to find the actual concentrations using that formula I gave you as well. All right, so now your paper should be looking a little bit better here. We should have some times right here all filled in. You should have taken those times and plugged them in. And we know that we had some concentrations here, right? And so these concentrations are going to fit there, right? So we have the same concentration changing every single time, right? This over here, we are not actually using this right now to find the rate because this is excess. There's leftovers. That's not the one that we were measuring. So hopefully we're all clear on that. So we know our concentration that's changing. It started here and it went to 0. So that's a change in concentration. And here we have the time associated with that change. And so we'll have our rate in molarity per second. So hopefully you were measuring in seconds, not some other weird unit. Okay, so we've got all that looking pretty good. Now, there is one thing I wanted to point out. This one is blank right here. If we had been in class, I would have come around and basically told you guys, hey, I want it to change colors at 55 seconds or something like that. I'd have given every group a different time. And you guys would have had to use the rate law that you're going to predict here to go backwards and figure out what your quantities of each of these would have needed to have been, and actually shown me that you could do it. But we're not in a situation where you guys could do that. You can't really prove to me what if your rate law is correct or not. So we're going to skip that. So this is basically being skipped right here, which means when we scroll into our conclusion questions, the last couple of them don't need to be done. So it says, what does the rate need to be in order? So we can skip this one. What concentration do you need? You can skip this one, and you can skip this one. And then this one would be skipped as well, because this would be where you actually tried to do it. So really all we're doing is we're just finding the rate law. Okay, now remember, we're leaving this one out. So technically it should be here. So if you want to put it in HSO3 minus, that's fine. But understand this is impossible for us to find, because I never ran trials where I kept this one constant and changed this one. It's way too much work. So we're just doing one of them. So this piece right here, if you want to leave it off, that would be totally fine. Okay, but you should be able to put this together completely. And that's your goal right here. It says to find the rate law for your reaction. We're going to leave out the HSO3 minus. You should find the rate law 3 times and average the order. This would have been really important, because when you get down into here, if you were actually trying to make it work, you wanted to have as good a data as you can. We're still going to do it. It's going to give us some practice. So when you're doing this, basically you'll have to be looking at your data, and so you're going to have lots of trials that you can compare. Since this is held constant every single one, you can compare trial 1 and trial 2 and trial 3, and trial 1 and trial 3. So you can compare all of these different ones, and you can find this order 3 times. So basically you'll just tell me you're going to compare trial 1 and 2 right here, and you're going to show me your work. And down at the bottom, you're going to say X is equal to something, right? And then you're going to say, okay, well, now we're going to look at trial, I don't know, let's say 2 and 3. And then you're going to look at trials 1 and 3. Okay, and so then at the end of each of these, right, you should have an X value, and I'd like you to average those. But somewhere I want to see a final rate law, okay? Then I want you to find the K for your reaction, okay? So at this point, you should be able to find the K very easily. This would be just like we would have done on our worksheet. So you guys are actually getting off lucky, not having to do basically the second half of this. So we still get to apply the worksheet that we did in class and see that it works out. Now, I am going to warn you, it's not going to be something nice and neat like 0, 1, or 2. Don't go rounding this thing off. Use an actual decimal if that's what you're getting for your orders, okay? Don't go rounding things off, trying to make them fit neatly into a 0, 1, or 2, because that's not going to be the case. We want to try and get it as exact as we possibly can. So let me know if you guys have questions, and I'll help you out the best I can.